some science juniorship. I studied on the URGS on Brazil. I now studying on a project of biological science about cannabis, and we basically searching for anti-inflammatory that is from a certain plant that is common here in Brazil, Rio Grande do Sul, that has cannabis-like properties, the peroticene or PET. We're doing this research on the budget of 200,000 reals, and I will be sharing the documents that we're doing, mainly educational, because the document is very heavy. The document has 300 pages, and this will explain how to read that document. Any questions? No? Okay. So without further ado, what is research apart from what we discussed so far? A map, clarify, design. Design we didn't do so far, but what approach can you answer the question credibly? That is important. Basically, this right here is the one that I mainly. If we were to be say this lecture, the quality of it is the quality is not very high because one, I went late. The design of my studies did not pair so well because the first intended document that is supposed to happen here was corrupted, so I cannot show. But it mainly focus on how can I design this lecture better on the next. For example, if the question was, what is the decision problem? A good lecture. What make a good lecture? How to map this? What is missing? How do I design to be? Even the question of this is a bad class, this is a good class. How even would you answer that upon design, the methods of protocol? And then you start to see that it becomes more complicated and you need other steps. You need to search the relevant evidence and found document, search strategy, search logs, screening rules. You need to approve what ethical, practical, or access conditions apply, consent material risk control, collection. How do you gather evidence consistently? There is a very tricky problem in science that you doing this the science can bias the result towards a certain outcome. There was a case on the World War One, World War Two, that planes got shot down and some returned. People looked at the planes and thought, holes on the wings. We should reinforce that. Do you know what is the problem with that reasoning of the planes and the holes? Survivorship bias. That is one of the most used examples that started with the research. Is because the planes that come back, they survived because the holes on the wings. If the holes on the other parts happen to be there, the plane would not return, for example. You will not have a plane with a hole in the pilot, so no one that come back had been shot, for example. Okay, back to the lecture. The focus will not lose scope here. How you analyze without overclaiming the results, the stem, the uncertainty, how you write a strong defensible answer, because it's important. We on science and discussions mean to say that things that are correct can be argued to be correct. You cannot have something that is correct and you cannot talk about it being correct. It's kind of a a limitation of the human language. To argue something is correct, you must be able to argue it is correct. You can have something that is correct and humans cannot talk about it, but science and research operates within the limits of human comprehension in human language. The question is how you pass some limitations. For example, communication. Here we are talking on the internet. I am showing my screen to pass some limitations of language because I am Brazilian. You guys are from other countries, I suppose. And there is a language barrier. How do you diminish that barrier? How you get more connected? How you mainly bridge those and show the same point of view and show that you can replicate it and explore. For example, one that I use here is share the paper that I will do later down on the end of the lecture. Mainly, it comes down to the step 10, and one of the most important and also the most tricky, share. Science is a collaborative game. You need to share your findings, even if mindful. Claim and science have a very, very sensitive thing. You cannot go around claiming things. You need to share that on this certain case you found such point, and for example, on this particular instance, on this particular day, on this particular time, you found something X. You need to share that data. Show that it's replicable, it's not replicable. You're not going claiming X. For example, some guy found that cancer cells had weakening from a certain drug. You can't go claiming, is the cure for cancer. It doesn't work like that. You need to be careful. It's about analyzing. Just because it's had an effect on the cancer cell, you cannot go generalizing. It's very important. When you do research, you are operating on the kernels of information. Anything that you say may change perception of people, and they might go around with the wrong kind of mind. Because, for example, I'm doing a project with an investor, and they think, on the first instance, that I am the creator of OpenAI. I am not the creator of OpenAI. I create a project within the tools that OpenAI differ. But the way that he spoke to the other guy, he sounded like my tool was the ChatGPT OpenAI. It was not. That is important. You need to be clear to pass the information, because remember, the information gonna be sent to the other person and the other person and the other person. You're gonna be a chain of persons that will understand, may hopefully understand what you're saying and pass to the next person. It's important to have it as clear as possible, because the information degrades over time. It's inevitable. When you pass information, is a telephone game. Have you played that game? Basically, the information gets corrupted over time due to physics. And that you need to be very, very, very mindful. Physics alters the very structure of information in research. You need to be mindful that you are inside a reality that is actively diluting information. So you need to think how those physics affects my research. For example, one of the most important is the detection altering results. For example, you measuring something alters the result of the thing itself. That is inevitable. But how do you reduce it? Questions thus far? Sorry if I am too. My speech might be a little bit too hard to understand. If anyone having problem understanding me, just say so. Let me check the comments if someone wrote something. Okay. Let me continue. On to the next topic. We're going to skip a bit of this. We're gonna read about it, but mainly let's focus about feasibility. Feasibility is one of the things that we, as people that are not in the field, in the deep field right now, struggles a lot because some projects that we made are not feasible. That is, it happens. You made a project and you go look at the budget and you look at that figures, 7 figures, that's not going to happen. The moment that you see, you need to think about the scope and project and look upon the mainly the fact that you can do some good research despite not having the budget. You can have replicability, that is a core of science, without needing the very expensive material, the very expensive research. You can have with quality and just discipline. Recent reviews, foundational works, primary studies, alternative reporting data, and the same thing of alternative views. You need to look at all of this to have a quality like research. Mainly, this one seems a bit weird, right? Why do you want dissenting or alternate views? Because of protection against bias, confirmation bias. The planes, for example, the planes example is very case of confirmation bias with survivorship bias. Confirming something that is not the case. What you need upon this is to look upon the feasibility and see a very important point. Do not mistake search failure for novelty. A topic may appear unexplored just because you use the wrong terminology, database, language, data range, or publication type. Confirm the gap through multiple routes and, when possible, ask the subject librarian or domain expert. Just because a topic seems neat and basically you failed the research does not mean it's novelty. That is one point. You need to be very disciplined around that. And again, what we discussed before, you need to have a mapping on a very fundamental level. The first here is the most important. A clarified view of the problem and questions helps a lot. Here upon the levels of importance, the most important thing that you need to do is clarify. And then on the last step, you need to share upon. Sharing information that is not clarified is more detriment than helps. Here upon the frameworks, building the questions and components. Frameworks include PICO, PICOT, population, intervention, comparison, outcome, time. Useful for intervention, effect, and questions. PO, population, exposure, outcome, and experience. Useful for exposure, experience, and associated questions. All those models you see in literature. The point that you need to do is have a clear focus on the terms, case, the intended meaning, and specify definitions. That means that you need to have to see how other people define that topic upon history or upon other instance of discussion, and see how your question and possible answer aligns with the term and definitions. One example is on mathematics that people get a bit complicated, is that mathematics has a very defined terms. Like a tensor is very specific. There is tensors and things that are not tensors. And you need to be very defined, especially of physics, that A causes B, and on larger scales you need to be very consistent and rigid upon those definitions. So you need to be careful. Other things that we on this document you're gonna see: research literature, evaluate sources and evidence, synthesis, design. I'm gonna leave you to read the document that makes a job explaining way better than I am explaining right now. But this is mainly the lecture upon physics. I have this document, and I will have another document that illustrates this. I will be sharing both. Thanks for having me, and this is the lecture. Sorry it wasn't too long.
That pretty much applies to any field of science and engineering,
Yes.
experimental